and we are going to record this. So if you're shy about recording, then I'm not sure what you should do. Yeah, so totally excited to talk to you about what I think of as really the future of computing. I think the days of working on our desktops are numbered, and we have access to much bigger data. The data needs to be sometimes securely accessed. The computing resources at our institution can be finicky. You have to deal with system administrators and other people, and you have to do a lot of configuration and so on. And so really, I think the cloud is going to be the way that things are going to happen in the future. And so I'm really excited to introduce a project that the Bioconductor team has been involved with for the last couple of years called AnVIL. AnVIL is sponsored by the National Human Genome Research Institute in the US, but it's not, participation isn't restricted to US researchers. So we'll learn a little bit about that today. We've got a number of workshops lined up. They're meant to be workshops, so that I'm hoping you follow along, and if you run into problems, we can tackle them at least in the context of the time that we have available, and that you find it interesting and exciting to learn about AnVIL and some of the possibilities. The workshops are meant to be modular-ish, and so you should feel free to miss a workshop if it's not fitting into your schedule, but then come back or tell your friends about things that you think that they'd be interested in learning about. I'll present some of the material, and then other people from around the bioconductor community will present others of it. So I'm going to start with today's material using R Bioconductor in AnVIL, which I've already opened, but I'll open again. We've got a little table of contents. I'll probably follow along the outline of this, and then, but I'll actually do things interactively, so I'll lose track of things. But the material is here so that you can keep track as we go along. This is the very first workshop. So we're just going to introduce the AnVIL cloud computing environment. We'll learn how to access AnVIL, which requires a Google account or an account linked to Google. And you'll see that that's because actually at the end of the day, someone pays for it, and we'll pay for it today, but in the long term, you'll need to figure out some other way of paying for it. And you use currently your Google account to do that. We'll explore some of the key parts of AnVIL related to workspaces and billing projects. And then we'll focus on interactive analyses within AnVIL, sort of one small component of what you can do, where we'll create a Jupyter notebook, which is one way of doing interactive computing. Really excellent, I think, actually, for pedagogical training types of purposes, and also for sharing reproducible results. And we'll also explore an RStudio environment, which is maybe more familiar to those of us who are regular R users. I've got some key resources here. I'm going to go to the first one, anvilproject.org, which just gives us a little bit of a sense of what's available. So AnVIL actually consists of several components. One is that it's a rich repository of what I'd call consortium data sets. So here we can see that, for instance, we host the 1000 Genome, CCDG, CMG, this convergent neuroset, GTEx, PAGE, HPRC, and other consortium scale data sets. And then one feature of this is that the data, such as this 1000 genomes, might be in the public domain and entirely accessible to you, or maybe it requires authentication, this CMG data set. And then AnVIL is actually a secure environment, so you'd have to gain access to this data set through the channels that regulate CMG, like dbGaP or whatever the authority is that gives you access. And then you'd have access to the data within AnVIL. So these are, your classic sort of large data sets, where if you click several of these boxes, you'd see that the total size of the data sets is getting up into the petabyte range. So there's huge data that's available here, and that's like the way that genomic data is going these days, huge data sets. And you can use AnVIL to perform analysis, say workflows on these very large data sets. We'll do a modest version of that. But you can think of those initial analyses as kind of like data reductions that often end up with data sets that you want to actually do the interesting stuff with, which is, explore them interactively. And that's more where I'm coming from, I guess. So we'll spend today introducing that kind of interactive analysis. You can see that this website is providing a pretty, it's growing still, set of resources for learning, news, forthcoming events, and so on. So that's a very quick introduction to AnVIL. And now what I wanted to do was go to this second link in the key resources. And I hope that you'll follow along, that you'll reach into your computer and click on this link yourself. And it'll take you to a page that looks like this. So this is the front of the AnVIL computing environment, where you access the data and where you perform computations. And I'm going to point to this item here, which I'm going to call the hamburger, not just because it's lunchtime here in the US, but it kind of looks like a hamburger. And I'm just going to click on it. And I meant to be signed out when I came here. And it'll say sign in with Google. So I hope you're following along. You've gone to get some lunch at the hamburger. Sign in with Google. You click on this. You get this dialog box that doesn't remain blank forever, but lists your Google accounts. And you choose the account that you want to use. So I'm going to use this account that I actually created specially for today. It's a naive account, mtmorgan.popup@gmail.com. And then it'll have logged me in. You can see it's got my name and Martin Morgan. And so I hope that you're following along and that you've logged in. I see Andrew's got the thumbs up. That's great. I don't know if other people want a thumbs up in the video part of things, or you can thumbs down as well. If a thumbs up from Charlotte, that's good. Yeah. Okay. Excellent. Great. So here we are at the AnVIL, and we've logged in. And the next thing I wanted to do was AnVIL is organized into these things called workspaces. And the workspaces, you'll see that there are a number of workspaces. They kind of coordinate the data that you have access to and the computational environment that you're going to act on that data. So I'm going to workspaces. Oh, and I see I've got one here that I wanted to delete. So just it prompts me to be sure I want to delete it. So hopefully you see this bioconductor workshop pop-up. I see Andrew's great. He's the perfect guy. I'm going to go with him. If he nods his head, I'm going to assume everyone's nodding their head, unless someone is very enthusiastic in the other direction. So this is a workspace that I've created just for this workshop. But you can see that there are new and interesting, by some definition, COVID, blah, blah, blah. This looks like viral sequencing. It's got a bunch of data sets that you can access that are linked to resources. It might have some notebooks, some Jupyter notebooks that you could do interactive analyses with. And it might have workflows that represent the transformation of big data to small data that you might write something in a workflow description language to explore. And you're actually able to do things with this particular workspace. I wanted to go back. There are a bunch of shortcuts. I'm going to click on this workspaces and go back here. A bunch of public workspaces. But this one is a workspace that I created, and I've granted access to you guys, specifically to you. And that's actually an interesting thing that we could come back to. What I wanted to do was I wanted to enter it. And actually, I wanted to make a copy of this workspace so that I myself can do my own computations. We could do this if this were like a lab group, maybe we'd share this workspace, but I'm going to make a clone of it, and I'd like you guys to do this as well. So I'm going to go over to this graphical icon, which I call a teardrop, these three vertical drops. So we've got hamburgers and teardrops. I'm not sure why hamburgers lead to tears, but that's the way it is. And you can see that there's this clone icon at the top. So I'm going to choose clone, and it'll ask me to provide a workspace name. So this is my own copy. The names actually have to be globally unique, I believe. So I'm going to name mine MT Morgan pop-up, but you should name yours something else. And I found that having a space in the workspace name can be problematic. So I tend not to put spaces in my workspace names. And then the next thing is this billing project. And you should see Deep Pilots Bioconductor. So someone's going to pay for the computation that you do. And for the purposes of the workshop, we've got some funds to do that. I should also say that probably over the course of this workshop, like even over the course of the 8-week period, we'll probably spend like $11 or something like that. The costs aren't prohibitive at all. But billing project, it should say Deep Pilots Bioconductor. If you don't see that, or if it says when you tried to clone the workspace, it said something dire about not having permissions or something like that, just reach out to Kayla with the credentials that you use to log into AnVIL. So here's our billing project, and then I'll just clone it. Time passes a little bit of time. And what it's actually doing now is it's making a copy of the workspace. So it's now my workspace, and anything I do in this workspace will be restricted to me. Nobody will be able to see it. Actually, I see when I created the workspace, it inherited this authorization domain. So I guess you can all see my workspace and make a clone of it, which is kind of interesting. I hadn't really thought about that, but nonetheless, I think if you went back to workspaces, you might actually see my workspace, and maybe you'd see other people's workspaces, or you'd at least see your own workspace. All right. So actually, I see my next step. Just while you're getting here, I'm just going to do a little bit of behind the scenes stuff. So pay no attention to the man behind the curtains here. Should have done that as well. That's all right. Okay, back to my workspaces and my workspace here. All right. So now we've got this workspace that we can do stuff with. If it were a richer workspace, and we'll see next week, there might be some data here. Maybe there'd be some existing notebooks that your colleagues who created the workspace had created, maybe some workflows. And what we're going to do is we're going to aim to make our first notebook, a Jupyter notebook, and add it to our workspace. So to do that, I'm going to go up to this sort of cassette recorder kind of thing. Probably people don't know what a cassette recorder is. It's a device used in prehistoric times to play rock and roll. And it says cloud environment none, and it has a cost. It's costing me less than $0.01 an hour to run no cloud environment, which is kind of reassuring. So I'm going to click on this guy, and it provides me with a cloud environment that I can create. And the default environment has, you can see over here, the most important one. They do it back to front, so the most important is at the end, kind of like senior author, right? So R403 is at the end. That's what we're interested in. But you also get Python and GATK on this environment. The default environment has a single CPU, a little less than 4 gigs of memory, and 50 gigabytes of persistent disk. And when you're running, it costs 6 cents an hour. and when it's paused, it costs less than a cent an hour. So 6 cents an hour isn't very expensive, and less than a cent an hour isn't that much. And then the persistent disk is $2 an hour. You can customize your cloud environment. So you could decide that actually your task needed 96 CPUs and 624 gigabytes of memory and 500 terabytes of, I don't know how large that can go, of persistent disk. And if you were to press the create button, you'd actually get those resources. So that's pretty cool. But I'm going to go back and not do that. I'm going to go back to the default settings and go with the minimum. Stick with this guy here. And I'm just going to create it. So I'll press that button, create. And actually, what happens now is that behind the scenes, Anvil is talking to Google, and Anvil is saying, hey, I've got this request for, I need a CPU, 3.75 gigs of memory, and a 50K persistent disk. So please give it to me. And Google's saying, right, I'm getting those, I'm marshaling those resources for you. And it'll take a couple of minutes. So we have to spend a couple of minutes here just talking. I hope that you've taken those steps, but maybe I can just pause briefly. I'll stop talking for a couple of minutes while this catches up. And maybe if you want to ask questions, you can unmute yourself and go for it.
Hey, Martin, this is Andrew here. Quick question, if you don't mind. So how would you describe this creating the Jupyter Notebook? Is it a shorthand scrap sheet? Is it a connection to the data? What's a good way to get me off and running with what the Jupyter Notebook does?
Yeah, you'll see how it works out. So you'll end up with something like a document where you can enter text, and then you can enter expressions like 1 + 1, other fancy expressions, and then evaluate those expressions and see the results, include pretty pictures. And then because you're running within the Anvil environment, you have access to, down here you see this Google bucket. You have access to a bucket that's specific to your workspace where you can store your results. And you also have access to whatever data has been shared within the workspace. So if it were, like if this were a lab workspace, maybe someone had uploaded an experiment, say the FASTQ files from an experiment. Maybe they'd uploaded the data to the workspace, and then within the workspace, everyone who had access to the workspace, so everyone in your lab, would be able to access that data and run workflows and do analyses on it. Or if it were consortium scale data, you'd also have access to that.
Martin, can I ask a question?
Yeah.
About, so we're using Google Authentication and Google Compute. Is there any scope for using AWS or things that we might have university agreements with and things like that?
Yeah, not yet. But actually, there's over the course of the coming year, so Anvil's still very much a work in progress. Not quite the answer that you're looking for, but over the coming year, we'll have access to Azure-based resources, so the Microsoft cloud. And I think that's really the first step to opening it up more broadly.
Thanks.
Yeah. Also, you mentioned a university agreement, and I think that's really interesting because, when you'll see that you can get some free credits, like $300 worth of free credits from Google to explore things, but at some point you're going to shift over and actually want to do work. And you might be tempted to stick it on your personal credit card, but that'll become unappealing after a while. And probably what you want to do is get your institution to establish a billing account that you can charge to. And that's probably a big obstacle to, at that stage, you actually have to talk to your institution. If they've already, they're sort of cloud friendly, then they'll probably be okay with it. But if your institution is like mine, a little bit smaller and not necessarily on the cutting edge of cloud computation, you have to have a talk with IT people and the
Yeah,
budget people and so on.
there'll likely be a lot of inertia about it, but for instruction, you mentioned earlier, and this seems really could be a sweet setup for teaching with,
Yeah,
for example, my university, they push AWS, so every student in every class is at least $50 by default
I see.
credit, so even if you have a large class, every student walks in and they're able to chunk away at least to a certain degree for a quarter for $50, and you can ask for more. And
Yeah,
that's all taken care of, just with their university login and all that kind of stuff. So
yeah,
it makes it a lot easier.
yeah. Yeah, like a progressive university like yours is going to be great. So, yeah. And you're really right about the teaching environment. I think that's actually one of the strengths of this sort of a situation. All right.
Yeah, thanks.
So that's great. Yeah, that's great. Thanks for asking. So I see that my cloud environment has been created. So what I'm going to do is I'm going to go to the Notebooks tab, and I'm going to create one of these Jupyter notebooks by clicking on Create a New Notebook. And it asked me to enter a name, my first notebook. And then to select a language. And you can actually change the language of the notebooks after the fact, but I'm going to choose R as my language, as opposed to, say, Swedish or anything like that. And then I create a notebook, and then I've got instantly my first notebook. So if I were sharing this workshop, anyone who had access to this workshop would see my first notebook under the Notebooks tab. And when I open this, click on it, I'll pay attention to this teardrop menu. I'll open it and it says, I opened this notebook in preview mode, and what I've got is this one cell that's unevaluated. And what I want to do is I want to edit my notebook. So I'm going to click on the edit. And what happens is that I've got now my notebook on the compute resources that I'd allocated, including the persistent disk. I've got my notebook there, and it's ready to go. And the way that Jupyter works is that you have these cells here, and you can enter into the cell. It's always good to start with things that you know the answer to, right? And then press run, and it spits out the result. And the reason for that is because it connected to R and asked R to calculate 1 plus 1, and returned, R said the answer is 2, and it incorporated 2 into the notebook. And then it created a new cell here. And you can see in input, this is the first input. Here's the next cell. And I'm going to go to this little drop-down menu that says code. And I'm going to switch to Markdown. And I'll say this is, let's say, a particular version of R. It has some core packages installed, including BioC Manager, which is the BioC Manager. For those of you who aren't from the Bioconductor community, BioC Manager is the main way in which you manage Bioconductor packages. So I press that, and I'll just press run again. And because the cell was marked down, it formats it as plain text. And so then I can, prove this statement. I could say, like, well, what is the R version string? And if I ask for BioC Manager version, what version? What is the version of Bioconductor that I have installed? And so I can press run again, and it tells me I'm running R version 403 and Bioconductor version 312. So this is current-ish, current at the time of the last at the last Bioconductor release. And the intention is for the R that you get by default to be the current R and Bioconductor at the time of the Bioconductor release. So every 6 months, this will be updated to the next Bioconductor release. So so that's great. Also here, you could ask about get WD. So that's like, what is the directory that I'm working with? And this is actually telling you the location on the persistent disk that you're currently at. Actually, it's that's not quite true. The persistent disk, the disk that's going to persist, is everything below this home Jupyter user location. So this is where you are, and you could ask about, well, I think you could say like set WD, switch to my home, and then run that code, and then maybe write get WD. So that says, okay, now you're here. You could ask, well, what sort of files are here? There's a notebook folder, but you could say write.csv, the empty cars data set into empty cars.csv, run that, and then you could look at the directory and see, now you've got empty cars CSV. You could say read CSV empty cars, and run that, and get a formatted table, and then plot MPG as a function of cylinders in empty cars, and get a pretty picture, and so on. And if you wanted to install a package, you could say BioC Manager install genomic ranges. I actually won't run this. I'll just put a comment here. So you could install packages that you need. And actually, I'm guessing, I've forgotten about the gory details, but I'm guessing actually that this runtime actually comes with some packages. So it didn't come with genomic ranges. So I'm sorry about that. So I guessed wrong. So you could actually install genomic ranges, and it would do all the usual things. It would install the package and so on. And then just a word about the underlying runtime. So this is actually based on a Docker image. The Docker image was created by the Bioconductor team, and it has the same flavor as the Bioconductor Docker images that we produce, so that it has almost all of the system dependencies that typical use of R would require, so that if you do install a package, it's likely to work. So that's kind of interesting. And you can install, whatever packages you want from, you could install CRAN packages. Probably we've got a library dplyr. I think there's probably like a keyboard shortcut as well. Yes. So we've got library dplyr. We could install packages from CRAN, from Bioconductor, from GitHub, from wherever we want. So that's great. And then the notebook is actually saved automatically. You could save it manually. You can change or restart the kernel. You can change the kernel to Python, and so on. You can select individual cells and delete them. I'll use the scissor icon to delete that cell. You can structure this document with headings, and there's a table of contents that you can view. So lots of fun things. So like just like a couple of use cases. One would be in documenting, doing reproducible research, where you write, these are the steps in my analysis. This is the first step, and then the code chunk that performed that step, and then I did these steps, and here's the pretty picture that summarizes the diagnostic plot, and so on. That's like one use case. Another is, as Barry was saying, that maybe you've prepared a notebook ahead of time for a class, and you're teaching students about some aspect of statistics or bioinformatics, and it's not so useful to have them make innumerable typos as they go through the analysis. They can come in here and, the basic steps are enter the cell, read the text, understand what it's doing, enter the cell, click the run button, and move on to the next step. And of course, you could make that more challenging by having some cells that required completion or whatever. So notebooks are actually pretty useful. Maybe you saw just up there, it's flashed there for a second, notebook saved is automatically saving the notebook.
There's a couple questions in the chat. Robert was wondering if there's a shortcut for the run key, or do you have to keep clicking run when you want to cell?
I think I guessed that on my Mac it's command return. Notice also that.
Go ahead.
I was just going to say, there's one, notebooks are they have some aspects that are great and some aspects that are just a little bit funky, but notice that this was the 4th cell that was evaluated, and this one that appears before it is actually the 12th cell that was evaluated. So that if the 4th cell had depended on what was ever up here in this cell, then it would be confusing, but that's just the nature of notebooks. All right.
Barry was saying that when he was trying to install a package in a notebook cell, it gives lib as unspecified.
Yeah, it works fine. It's just where it's installing it.
Sure.
Yeah.
I see. You used install.packages, Barry, or?
Yeah, I was just trying cran and then Bioconductor just to see where it would go.
Yeah, actually, I'll just create a new cell here, and I guess I'll create it in the middle of this document. But so in R, there's this variable called libpaths, and actually there are multiple places where packages are installed. I think that most packages are here, and that new packages that you install are intended, like BioC Manager will install them in this location here.
Yep, perfect. Thank you.
And then one more question of, once I install a package, do I need to reinstall it the next time I run the notebook?
No, so that's actually pretty interesting. So the the notebook is saved automatically, but also this cloud environment, it has it'll shut down after a certain amount of inactivity, but it's kind of paused. It doesn't go away. And so the next time you come back to AnVIL, you might have to start up your cloud environment, take a couple of minutes, but then everything will still be there, everything on the persistent disk. All right, we better get to the next part of things. So I'm just going to go back to my workspace. There are a bunch of shortcuts. So up here, if you click on it says workspaces goes to deep pilots, bioconductor, blah, blah, blah. If you click on this guy, it takes you back to the dashboard. And what I wanted to do was I wanted to switch my cloud environment. I'm doing this. I think that actually, a typical use cases or user would probably choose a cloud environment, basically stick for it for many weeks or months. But I'm going to flip-flop, and I'm going to switch over to a different cloud environment. So I've just gone up to the cloud environment, and I've clicked here on the cloud environment, and it has application configuration, and there's a drop-down menu. So I'm going to just click on the drop-down menu, and I'll scroll down, noticing that there are different pre-configured environments. There's also last year's R and Bioconductor. And then down here, there's this RStudio environment. And again, this has been produced by the Bioconductor group. So I guess we're a verified partner working in collaboration with AnVIL. And it's, again, if you know the Bioconductor Docker image, it's based on the Bioconductor Docker image tailored to the AnVIL cloud and including RStudio. So I'll choose that and go with the CPU memory defaults. And here the persistent disk is here. If I chose delete environment options, then I could actually delete my persistent disk. And then if I delete my persistent disk, I would have lost whatever I'd saved on the persistent disk. The notebook would have been saved, but if I'd stored like that empty cars file, it would go away. So I probably don't want to do that unless I'm giving it some thought. I'll click on the next button, and it says I need to shut down your old environment and start up the new. So I'm just going to click that, and sort of behind the scenes now, it's saying, "Hey Google, I don't need those old compute resources. I still need the persistent disk because we didn't get rid of it. So you can have that old CPU back with the old runtime, but give me a new CPU or however much I wanted with a runtime that's capable of using RStudio." And so now we're waiting for a couple of seconds for that to happen as well. And maybe we could take questions again if you want to unmute yourself or if there are things in the chat.
How do we know when it's updated? It looked like mine already clicked through, or my screen looks like yours.
Does it say up here under cloud environment, it says creating? And it'll switch to running when it's ready.
Got it. Thank you. Is there a cost associated with toggling back and forth, or you can do it as frequently as you'd like?
Yeah, you can do it as frequently as you like. So each runtime and persistent disk, well, this is the runtime cost. So it costs a certain amount, and it's charged that amount when it's running. It can be paused manually or automatically, and then it's cost much less. And if your runtime is bigger, multiple CPUs or gigabytes of RAM, then the cost is more per hour. But you could imagine 6 cents per hour for a semester isn't very much money. 6 cents of usage hours, so it's not expensive. All right. So I've got my cloud environment. Were there other things that we can just pause on here while we're going through? All right. So at some time in the future, like in the next, say, 6 months, we'll actually have a slightly different interface where we can access our Markdown documents under this Notebooks tab. But currently, the deal is that you go up to this R icon up here, and you click on it. And you'll start to recognize our friend RStudio. I think I can probably change the appearance. So it's a little bit more visible. And so now we've got this RStudio environment, and it's in our browser, as RStudio often is, but it's actually running on the in AnVIL on some CPU that's been provisioned by Google. So you can, verify that 1 + 1 is still equal to 2. Our version string is that, and BioC Manager version is 3.12, and away you go. You can use R to do whatever you want. So great. And again, the sort of philosophy is the same as before. So probably there are packages that are already installed, and other packages. I'm sort of surprised that genomic ranges isn't installed, that aren't yet installed but could be installed. Maybe we can come back to that in just a second. Yeah. And then, you know, in RStudio, there's this Files tab, which is like a picture into the home directory. So actually, in this this folder here, you can drill down and see this is actually where the notebooks were kept. But then I can also do whatever I want, and this is on my persistent disk, so I can call it whatever I want here. So I can create a folder, you know, my analysis, and I can drill down into it. I can go to the file and create a new R script, and then save it to my analysis, and then you know, close this, go away, come back another day, open it up again, and here we are. All the rest of it. So everything is just like you'd expect in RStudio, and so on. So you can plot MPG as a function of displacement in the MT-cars data set. You get a pretty picture here. You can manipulate it or publish it or export it as an image that's saved to your local disk, whatever you'd like. I think actually that's exported to the cloud environment.
May I ask a question, Martin?
Yeah.
The file mtcars.csv that we created before in the Jupyter notebook, would we be able to access it from here?
So I think I was actually a little bit surprised that we weren't able to access it. Just as we, you know, I go through the demo and I'm expecting it to behave one way, and actually that was a little bit surprising. I was expecting the persistent disk, the entirety of the persistent disk, to have been shared. So I think that it should be. I think that we'd have to I'll do a little bit of investigation. So I think we needed to save it in a slightly different location on the computer, on the persistent disk. So
you're saying the disk is indeed the same, but maybe we only see a subdirectory of it right now.
That's right. Yes, I think I think it has a Jupyter user subdirectory and a RStudio subdirectory, and they haven't been shared the way that I was expecting them to be. So, but I'll look into that because I think that should be possible.
To feed off of Michael's question, that MT-cars data set, that was something you created for this purpose. It's clearly not biology, right? Did you just have this demonstrated wise pulled up?
Yes, it's R actually comes with a number of data sets. So MT-cars is the Motor Trend Cars data set from like 1923 or something like that. So this is, excellent. If you look up $MT-cars, right, that provides the help. 1974 Motor Trend Cars with these things that are built in. So. there are some more biologically relevant data sets that we should probably use, but MT-CARS is a very familiar one.
Martin, I put a question in the chat, and I don't want it to derail you if it's too off topic or too obscure, but if I was going to flip over to the terminal tab in RStudio and run some Unix commands or install something, or put some bioinformatics other software on there in the machine that wasn't there, and I wanted sudo, what would be the best way to set the sudo password? Or
actually, so that's a good question, but I actually think that the answer is
come back to me later if it's too obscure.
I think you actually already have sudo privileges here, or at least privileges enough to. So it's an Ubuntu image. So
the default username would be Ubuntu, and the password would be whatever you set the VM up with, right?
So what would be a good sudo command that I could do that wouldn't rm-rf? But I think that I actually have enough permissions just as the RStudio user to say install system packages and so on. But
okay.
I'll check on that. That's great. Yeah.
Thanks.
I did also want to mention in the Jupyter, when we were running Jupyter, you might have seen an icon over here. I'm not sure what it's supposed to be. I think it was a vertical bar and an arrow, and it would actually open a console. Which would be the equivalent of doing this, like a terminal.
Yeah, it looked like a little terminal icon, a little square with the thing. Yeah, exactly.
All right. Anything else? Okay, that's great. So maybe I'm basically at the end of the material that I wanted to present, but it's actually we've covered quite a bit, and maybe we can just go back and just walk through that one last time, just to remind ourselves what went on. And maybe also, just notice, so I've just logged out of my account and I'm going to sign in with Google. So we learned about that. I hope you guys are all set up there. And the hamburger menu allowed us to go to workspaces. I had this workspace set up for you, and to do computation on it, I chose to clone it and made my own workspace here, and then I created a cloud environment that initially I created the Python-based environment, but the second time round I created the RStudio environment here, and in each of those environments I was able to customize the amount of memory and CPUs and disk space that I had available. So I was able to do that. And then in the Python environment, I was able to create a Jupyter notebook, which I can preview. Even though I'm running RStudio, I can preview my notebook. And if I were running the Python-based environment, I could actually edit it and update it. And share it with my colleagues. But as I'm running RStudio, I also have access to RStudio here, the full-featured environment for working in R. Returning to this document and the table of contents, I've summarized what we've accomplished. Accounts and workspaces, Jupyter notebooks, and the R Cloud environment. And if I were to give you some homework, I think it'd be great if you tried to. So right now you're working on on the billing account that belongs to this workshop. And I'm actually going to turn it off at some point in the next hour or so. And that'll mean that you don't have access to anything that you've created over the last hour. So hopefully you haven't created anything terribly valuable, but I'm going to turn it off and you won't have access to the compute resources or anything like that. But presumably what you'd like to do is, to continue to explore Anvil. And the easiest way to do that is to set up billing, set up your own billing account. And with a $300 Google credit to explore Terra. And $300 will actually go quite a long way at this stage of the game. So I'd encourage you to follow through with this. I'm going to just open it up because it's actually relevant here. So this is actually the support site of Anvil and Terra. And it's also available under the hamburger if you go to support, these tutorials and how-to guides. And it's actually really good that the Broad who makes Anvil and Terra, the Broad Institute has professional documentarians who write excellent documentation. You can see that Ali updated this 5 days ago, so it's current. It tells you how to set up a Google Cloud Project billing account. You go to some place you click on here, and you end up with this place where you can try for free, and then it gives you $300 worth of free credits that you can then in Anvil you can create your own billing account. So you can see that I can create a billing account associated with my login, and I hadn't actually done this. I hadn't actually created my own billing account under this account, but I'll cancel it for now. But presumably it's just a click away, and then that'll allow me to have my own billing account, so that when I go to a workspace and choose to clone it, instead of billing Deep Pilot's Bioconductor, I can choose my own billing account, the credit card that's going to be charged, or the Google Cloud credits that are going to be charged to it.
Martin Axel had a question in the chat here.
Yeah. I can't really see the chat in my setup, so if you could.
Yep. I tried password RStudio and it told me that the user RStudio is not in the sudo group and the incident will be reported. So yeah, it does. There seem to be a few instances in the chat. Maybe you can grab some examples before we end, and that there was password that was still needed. Okay,
that sounds great. I'll follow up with that. I'll add a section to this document here. Maybe I'll do it just now. I have some frequently asked questions that I ask myself, but let's add a question here about. So this is like. And another one was about sharing data between Jupyter notebooks and RStudio. So I'll try and find out what the answers to those are and fill them in the documentation.
Maybe just to add to the second one, I don't think I have a use case to do that sharing of data between these two. It was more to understand how the persistent storage is set up.
Yeah, that's a great question.
It seemed also the library paths were different, so you didn't share the same R library.
Yeah, actually, the underlying operating system on the Jupyter notebooks is Ubuntu 18.04, and under the RStudio instance, it's Ubuntu 20.04. So actually, the runtimes were different. We're trying to harmonize them, so at the next release, we're hoping to build everything on a common architecture. Yeah. Oh, that did remind me, Charlotte, since you asked that. There's just one fun thing that I wanted to mention. I think we've got my RStudio here. So this is a little bit in the weeds, but BioC Manager repositories. So we actually know the environment that we're running on. Like I said, it was a particular operating system, Ubuntu 18.04. And because of that, and because of some work that the RStudio people have done, we can actually install packages from RStudio, and then for CRAN packages, these are actually binary packages. So if I say BioC Manager install, say dplyr, just as an example, it's already installed, but just run that. And you can see that what happens is it runs out to, looks like there's some packages that require updating. It runs out to this CRAN and pulls down these packages, 1, 2, 3 packages that I guess needed updating, and then it installs them. But you notice that it installs them as binary packages. So even though Erlang has a ton of C++ code that would normally take forever to compile, it installs instantly. And the same is true for the other packages. I won't update these. So that there are these binary package installs. And that's actually kind of pointing to just something interesting about these cloud-based environments, in that they provide a standard environment where somebody else, like the people who are experts at it, can make life easier for you. So that instead of taking 15 minutes to install these 3 packages, it took a couple of seconds, 10 seconds. And then you'll see later on that there are other things that are being done currently and that will be done in the future to make life easy for you as you use the cloud environment, removing some of those system things like needing to use the sudo should be reduced already on these images, but that's kind of interesting.
Not having to install from source on the Linux box is going to be a huge time saver, absolutely.
Yeah.
But if you just want to run sudo, apt-get update, if you're, if something's always out of date,
yes, right.
You can't do it, unless we know what the setup is, or we can set it.
I'll look into that a little bit. I'll mention just because that's a relatively advanced feature, but you can actually provide your own custom environment, provided this is actually not quite right. Terra Jupyter Notebook Space Images, you can provide your own Docker container that's tailored to have exactly the software that you need, and not use one of the pre-configured environments. So if you had your lab was working on some suite of informatics tools that you wanted to make sure was consistently versioned and so on, you could create an image and tell everyone within Anvil use that image. Pretty interesting as well.
Yeah, that's a really nice feature. Absolutely.
Martin, one question. My university account is on Google, so the university pays for this kind of G Suite app account where you get Google email, but with the domain of your institution. does this kind of Google account is collision with in any way with this Google Cloud, or does it have any advantage? Do I get any kind of free credit or anything, or it's like any other Gmail account?
It's like any other Gmail account. It allows you when you signed in. I guess you signed in. It says sign in with Google, but I guess you signed in with your university account, right?
Correct. Yeah.
Yeah. So it kind of did the credentials. That having that account gave you the credentials to sign in. But then if you went and I guess I need to be signed in. But when you went to create a billing account, it would have when you created a billing account, it wouldn't have given you free credits. You would have had to go through some steps to arrange for payment, or maybe they're free credits that are provided by your institution, but that's like an institutional kind of thing.
Okay, thanks.
It might be, Robert, that your institution actually does have a relationship, like they've gone the G Suite route, so maybe they actually do have a relationship that makes it really straightforward for you to set up a billing account.
Mm-hmm. That could be great. Yeah.
Yeah.
So
All
Martin,
right.
thank you very much, Martin, for doing anything. I know you're at your time limit, but I guess you're going to talk about teaching with it in the future in a future workshop.
Yeah.
But have you used this in Anger for teaching lots of people, apart from today, obviously, where you're doing it fantastically, teaching us? But have you tried it with 100 students and things like that?
Well, so we've done larger workshops, like on the short term, like like a 3-hour workshop with hundreds of people. And I think there's a workshop later that if you visit this events, I think that one of these workshops, the biology of genomes, I think it's the biology of genomes, has hundreds of people who will participate in a workshop. But I wanted to say that Levi has used it in a more academic setting, where he's taught master's level students a master's level course using AnVIL, so like over a semester.
Fantastic. Thank you very much, Martin.
Yeah. Okay. Well, I hope I'll see you next week or at some future session. By all means, tell your colleagues who might be interested to sign up, and we'll make sure that they have their credentials added so that they can participate in the next round. Thanks for attending. I hope you found it useful.
That was great, Martin. Thank you so much. Have a good one. Bye now.
Thank you very much.
Martin. We'll see you soon.
Thank you very much.
Much appreciated.
All right. See ya.